Good morning, dear students. Now we are moving to next point of this chapter that we started of chapter number 3, which is vector algebra and analysis. We was I showed you the vector identities. So we proved five vector identities. Now we are moving to vector identity number 6. Okay, and after that we left with only one vector identity, which is vector identity number 7, and after that we are going to solve problems. So first of all, we are going to start with vector identity, which is identity number 6. Okay, so here, so first of all, sixth vector identity is that del dot a cross b is equal to b dot del cross a minus a dot del cross b. This identity we have to prove. Okay, so identity 6, left hand side of this identity is del dot a cross b. Okay, so before that we know that vector a is ax I cap, ay j cap, and az k cap. Vector b is bx I cap, by j cap, and bz k cap. Okay, so first of all we must need to find out cross product, which is a cross b. Okay, so cross product a cross b is I cap, j cap, k cap. Here we have ax, ay, az, bx, by, bz. So this is equal to I cap into, okay, coefficient of I cap into ay bz minus az by, okay, minus j cap into ax bz minus az bx plus k cap into ax by minus ax by minus ay bx. Okay, so these are the coefficients. Now on the left hand side we have to take dot product of a cross b with this del operator. So this is the divergence of a cross b. So del dotted with a cross b is equal to, now here we have to take derivative. We know from definition of divergence we have to take derivative of this term with respect to x, derivative of this term with respect to y, and derivative of this term with respect to z. Okay, so here we get first term as partial derivative with respect to x of ay bz minus az by. Okay, plus partial derivative with respect to y of this term, and this term is minus ax bz minus ax bz plus az bx. Okay, so that minus minus sign will become plus sign, and plus partial derivative with respect to z of this term. Okay, and z term is ax by minus ay bx. Okay, now this is equal to, Now this is equal to, on the right hand side, what we will have. Okay, this is equal to, we have to take differentiate this term with respect to x and this term with respect to y. Okay, so if we differentiate this term with respect to x, we have to use product rule, and we get term like this. First of all, derivative of this term will remain constant. So here we get two terms for this term, two terms for this term. Okay, so we can write this as partial derivative of ay with respect to x, bz as constant, plus ay, and partial derivative of bz with respect to x, minus partial derivative of az with respect to x, by, minus az into partial derivative of by with respect to x, plus next we have to differentiate this term. So partial derivative of ax with respect to y, bz, plus ax partial derivative of bz with respect to y. Okay, so this is the derivative of this term. First of all, derivative of x with respect to y, then bz, and afterwards ax as it is, and derivative of second term. Now we have to differentiate this term. Okay, now here I forgot this minus sign, so here we have this minus sign, plus derivative of this term, derivative of az with respect to y at that time, bx as constant, plus az into derivative of bx with respect to y. Okay, plus here we have to differentiate this term, partial derivative of ax with respect to z, by, plus ax partial derivative of by with respect to z, minus partial derivative of ay with respect to z, bx, minus ay partial derivative of bx with respect to z. Okay, now this is equal to, now here if we look at the right hand side, here we have b dotted with del cross a, and here we have a dotted with del cross b. So likewise we have to collect the terms which include b dotted with del cross a. So the terms which include b dotted with del cross a, we must have bx multiply by this term, by multiply by this term, and bz multiply by this term. So we have to take all the terms which includes bx, by, and bz. Okay, so here we have this term bx. Okay, and another term for bx is there. Okay, so I will write this as partial derivative of az with respect to y, minus partial derivative of ay with respect to z multiply by bx. Okay, now term for by, plus if we take term for by, here we have this term for by. Okay, and another term for by is here. Okay, so we have to take by as common, and we remaining with partial derivative of ax with respect to z, minus partial derivative of az with respect to x multiply by by. Now remaining term for bz, here we have this first term of bz, and here we have second term. So plus partial derivative of ay with respect to x, minus partial derivative of ax with respect to y, and multiply by bz. So here we have this term of bx, by, and bz. So that will form b dotted with del cross a terms. Now remaining terms are included in this term, okay, on the right hand side. So if you take minus as a common, then we have to collect the terms which include ax, ay and az. Now see, term of ax, so here we have this term, okay, and another term for ax is there. So if we already taken out minus sign common, so partial derivative of by with respect to z minus partial derivative of by with respect to z, and here coefficient of ax is partial derivative of bz with respect to y, okay, then plus term for by, sorry, ay. Here we have this first term and here last term, okay. So coefficient of ay is partial derivative of bz with respect to x minus, here we have partial derivative of bx with respect to z, here we have this term ay. So here coefficient is ax plus last term which is az, okay. So az and az, okay. So here partial derivative of bx with respect to y minus by with respect to x multiply by az, okay. So here we have all these terms. Here we have bx, by, bz, ax, ay, and az terms. Now, along with this, if you find del cross A, if you find out del cross A, you know how to find out del cross A. You have to take determinant I cap, j cap, k cap. Okay. So curl of vector A is like this: I cap, j cap, k cap. Del coefficients are dabba by dabba x, dabba by dabba y, dabba by dabba z, and coefficient of ax, ay, and az. If you solve this curl, you will get I cap coefficient as dabba az by dabba y minus dabba ay by dabba z. Okay, this term. So this is I cap coefficient. We are multiplying with I cap coefficient of vector B. So this term, okay. Similarly here, this term is before and this term is afterwards. Okay. See, j cap minus j cap into partial derivative of az with respect to x. Okay. And minus partial derivative of ax with respect to z. Okay. So this term is the j cap coefficient of del cross A, and we are multiplying with this with vector, sorry, vector, y j component of vector B. Similarly, this is z coefficient of this term C, partial derivative of ay with respect to x minus partial derivative of ax with respect to y. So this term is nothing but we get B dotted with del cross A. Okay. If you solve this term, you will get first term. Similarly, if you find out del cross B dotted with vector A, you will get this term. Okay. So by using that property, we can say this is equal to, on the right hand side, this term is nothing but, this is equal to first term, okay, is nothing but vector B dotted with del cross A minus second term is vector A dotted with del cross B. Okay. So with this we prove identity number 6. Now we are proving identity number 7. So vector identity number 7 is del cross vector A plus B is del cross A plus del cross B. Okay. So again here vector A is Ax I cap, Ay j cap, and Az k cap. Vector B is Bx I cap, By j cap, and Bz k cap. Okay. So vector A plus B is Ax plus Bx I cap plus Ay plus By j cap plus Az plus Bz k cap. Okay. Now we have to take curl of vector A plus B. So curl of vector A plus B is equal to Now we have to solve this determinant I j k. Okay, dabba by dabba x, dabba by dabba y, and dabba by dabba z. And again coefficient of vector A, here we have ax plus bx, ay plus by, and az plus bz. Okay, now this is equal to I cap into, again we have to solve this determinant to get right hand side of this equation. So I cap multiply by partial derivative with respect to y of this term. Okay, so if you take partial derivative with respect to y of this term, so that will become partial derivative of az with respect to y plus partial derivative of bz with respect to y minus partial derivative with respect to z of this term. Okay, so partial derivative with respect to z of ay minus partial derivative with respect to z of by. Okay, minus j cap into, we have to take partial derivative with respect to x of this term. So dabba by dabba x of az plus dabba by dabba x of bz minus partial derivative with respect to z of this term. So partial derivative of x with respect to z minus partial derivative of bx with respect to z plus k cap into, okay, we have to take partial derivative with respect to x of this term. So dabba by dabba x of ay plus dabba by dabba x of by minus dabba by dabba y, okay, differentiating with respect to y of ax minus partial derivative with respect to y of this term. So this is the k cap coefficient. Now this is equal to, see, if you see at the right hand side, here we get addition of del cross A and del cross B. So we have to take together the terms which include A, and in another bracket we have to take terms which include del cross B. So first of all, term of vector A. So I cap into partial derivative of Az with respect to y minus partial derivative of Ay with respect to z minus j cap into partial derivative of Az with respect to x minus partial derivative of ax with respect to z plus k cap into partial derivative of ay with respect to x minus partial derivative of ax with respect to y. Okay, plus I cap into, now we have to take out terms which include b. Okay, so first of all I cap into this term and this term. So partial derivative of bz, okay, with respect to y minus partial derivative of by with respect to z minus j cap into partial derivative of bz with respect to x minus partial derivative of bx with respect to z plus k cap into partial derivative of by with respect to x minus partial derivative of bx with respect to y. Okay, so this first term in this step what we did, या स्टेप मध्ये काय केलं आपण की फक्त ए आणि बी च्या टर्म सेपरेट आउट केले. नाउ इफ यू सॉल्व डेल क्रॉस ए, ओके, डेल क्रॉस ए काय असेल तुमचं इथं फक्त ए एक्स ए वाय आणि ए झेड असेल. हे जर डिटर्मिनंट तुम्ही सॉल्व केलं तर तुम्हाला हे भेटेल. ओके, सी आय कॅप partial derivative of az with respect to y minus ay with respect to z. सिमिलरली जर तुम्ही डेल क्रॉस बी हा डिटर्मिनंट सॉल्व केलं तर डेल क्रॉस बी ला काय असणार आहे, इथं बी एक्स बी वाय आणि बी झेड असेल. आपल्याला काय भेटेल, आय कॅप partial derivative of bz with respect to y minus by with respect to z, okay, minus j cap partial derivative of bz with respect to x minus bx with respect to z. याला जर तुम्ही सॉल्व केलं तर तुम्हाला हे भेटेल. ओके, सो फर्स्ट टर्म इज नथिंग बट डेल क्रॉस ए अँड दिस टर्म इज नथिंग बट डेल क्रॉस बी. So on the right hand side we can write this is equal to del cross A plus del cross B. Okay, so curl of vector A and curl of vector B. So with this we finish identity number 7. Now with this we finish theory of chapter number 3. Chapter number 3 is a very big chapter. Okay, now we are going to solve problems based on this chapter. So there are above 20 problems, I think around 26 or something problems which are based on this chapter. We are going to solve all those problems. So first of all, first problem. Problem number 1, find problems based on this chapter number 3. Find angle between vector A which is 2i 2j minus k and vector B which is 6i minus 3j plus 2k. Okay, so these are the two vectors and we have to find out angle between vector A and vector B. So to find out angle we are using property of dot product. So we know that from definition of dot product, vector A dot B is equal to magnitude of first vector, magnitude of second vector into cosine of angle between them. So theta is the angle between these two. So from this equation we can write cos theta is vector A dotted with vector B divided by magnitude of vector A into B. Okay. So first of all, call this as equation 1. Now vector A dotted with vector B. So we have given components of vector A and vector B. So first of all, dot product of these two vectors. So 12, okay, minus 6, okay, and minus 2. So 12 minus 6 minus 2. So this is equal to, so 12 minus 8 which is 4. Okay, so A dot B is 4. Now magnitude of A into magnitude of B. So vector A magnitude, या वेक्टरची मॅग्निट्यूड काय असणार आहे, स्क्वेअर रूट ऑफ this 2 square plus 2 square plus 1 square. Okay, so 4 plus 4 plus 1. Okay, So that will become 9, which is 3. And magnitude of vector b is square root of square of 6, which is 36, plus square root of minus 3, which is 9, plus here we have 2, which is 4. Okay, so this is equal to, so 49, which is 7. Now from equation 1, cosine of theta is equal to a dot b, which is 4 divided by, this is 3 into 7, which is 4 divided by 21. And angle between them is cos inverse of 4 by 21. Okay, so on your scientific calculator, find out this value, cos inverse 4 by 21. Okay, so I think that value is 79 degree. Okay, now we are going to solve problem number 2. So problem number 2 is, find p such that vector A is 3i plus pj plus k, vector B is 4 minus 2j minus 2k are perpendicular to each other. Okay, so from property of dot product, we know that we already studied in dot product. If vector A is perpendicular to vector B, then their dot product vector A dot B is 0. In this case, their dot product is 0. So we have to find out dot product of these two vectors. So vector A dotted with vector B is equal to, you see, what is their dot product? So here we have 12. Okay, so minus 2 into P and minus 2. So 12 minus 2 into P minus 2 is equal to 0. So what the equation we get? Minus 2p, okay, is equal to, so 12 minus 2, which is 10, and right hand side we have minus 10, so p is 5. Okay, so using the property of dot product, we can find out value of p, which is 5. Now problem number 3, we have to solve problem number 3. So first of all, statement of problem number 3, show that magnitude of vector A cross B its square plus magnitude of vector A dot B its square is equal to A square plus B square. So let vector A cross B is equal to, what is A cross B? We know that it is AB sine theta into n cap. N cap is the unit vector perpendicular to vector A and B plane. Now magnitude of vector A cross B is equal to, so magnitude of this and magnitude of n cap. n cap चे magnitude किती असते नेहमी 1. So this is AB sin theta. Okay, similarly by definition of dot product, A dot B is equal to, A dot B काय असेल, by definition AB cos theta. Okay, so call this as equation 2. Now squaring and adding equation 1 and 2. So here A dot B घेतला आपण AB cos theta. Equation 2 याला म्हणा magnitude of vector A dot B is equal to, that is again AB into cos theta. Okay, याची जर magnitude घेतली तुम्ही तर ती काय असणार आहे AB cos theta. Now squaring and adding equation 1 and 2. लेफ्ट हँड साइडला काय भेटेल आपल्याला, A cross B magnitude त्याचा स्क्वेअर प्लस A डॉट बी मॅग्निट्यूड त्याचा स्क्वेअर इज इक्वल टू राईट हँड साईडला काय होईल ए स्क्वेअर बी स्क्वेअर साइन स्क्वेअर थिटा प्लस ए स्क्वेअर बी स्क्वेअर कॉस स्क्वेअर थिटा. So this is a square b square. Okay, so here we will get right hand side, this is magnitude of first a vector, this is magnitude of b vector. Okay, and that is nothing but right hand side. Now with this we finish problem number 3. Now we are going to solve problem number 4. What is problem number 4? Determine unit vector which is perpendicular. Determine unit vector which is perpendicular to plane of vector A, which is 2i minus 6j minus k, and vector B, which is 4i 3j and minus k. So we have to find out unit vector which is perpendicular to plane which is formed by these two vectors. Okay, now let we know that A cross B is what? A B sine theta into n cap. Here n cap is unit vector perpendicular to plane of vector A and B. Okay, so this unit vector is perpendicular to plane of vector A and B. So from this n cap is equal to A cross B divided by AB sine theta. Now this is equal to A cross B divided by AB sine theta. AB sine theta is magnitude of vector A cross B. Okay. In previous problem, we have shown this magnitude of A cross B, which is AB sine theta. So n cap is what? A cross B divided by magnitude of A cross B. So call this as equation 1. Now we have to find out cross product of these two vectors and magnitude of that vector. So let A cross B is equal to I j k. Now coefficient of vector A are 2 minus 6 minus 1. Okay, and vector B 4 3 minus 1. Okay, now this is equal to I cap into here 6 and minus 3, which is 9. Okay, we have to solve this determinant. Minus j cap into minus 2, okay, plus 4, minus 2 plus 4, which is 2. So minus 2 plus 4 plus k cap into 6 plus 24. 6, okay, plus 24, which is 30. Okay, now this is equal to 9 I cap minus 2 j cap plus 30 k cap, and magnitude of vector A cross B is equal to I think in your book I have written some coefficients slightly different. That's why we get this vector as different from your book, but procedure is same. Okay, follow this procedure, you will get the answer which is in the book. Now magnitude of vector A cross B is equal to under root of 81 plus 4 plus square root of 30 is 900. Okay, so this is equal to under root of, so 985. Okay, so n cap is equal to, put in equation 1, we will get unit vector n cap as a cross b divided by this, so 9i, okay, minus 2j plus 30k divided by square root of 985. So this is the unit vector which is perpendicular to plane of vector a and b. Now this vector is directed in the direction of a cross b. So B cross A is also unit vector which is perpendicular to plane of A and B. So here we have these two vectors, what one which is have plus sign and another have minus sign. Why? Because suppose this is plane of vector A and B, and if you find out A cross B is like this, so this is perpendicular to A cross B. Similarly, vector which is into this board is also perpendicular to that. Okay. Now problem number 5. If magnitude of vector A is equal to magnitude of vector B, then prove that vector A plus B is perpendicular to vector A minus B. So what is given in problem number 5? Vector A is equal to vector B. So magnitude of vector A is equal to B. So A square is vector A dotted with A, and B square is vector B dotted with B, and again magnitude of vector A is same as magnitude of vector B, which means, why, if you take square, okay, on left hand side and right hand side, so that will become this. So we can write from this, vector A dotted with A is equal to vector B dotted with B. Okay, now we have to show vector A plus B is perpendicular to vector A minus B. So their dot product must be 0. Okay. So vector A plus B dotted with vector A minus B is equal to. If this dot product is 0, then we can say that these two vectors are perpendicular to each other. Now this is equal to, first of all, A dotted with A, so that is mod A square, minus, if you dot this vector with another vector, so minus A dotted with B plus vector B dotted with A, okay, and minus vector B dotted with vector B. Okay, if you solve this dot product brackets, so this is equal to mod A square and A dotted with B and B dotted with A are the same quantities. Okay, so that is from the property of dot product. A dot B is equal to B dot A. So this will cancel, and here we have minus B square. And from equation 1, okay, A dot A is equal to B dot B, means mod A square is equal to mod B square. So again this is equal to 0. And if vector A plus B dotted with vector A minus B is equal to 0, then vector A plus B is perpendicular to vector A minus B. Okay. So with this we finish our problem number 5 over here. Remaining problems we will see in our next lecture. Thank you.